Hello, everybody, and welcome to lesson 5.2 in our textbook. It is on page 270. So this lesson is on parallelograms, and the word properties means rules, some kind of things about, let's just say, parallelograms. And the objectives is to understand or to use relationships among sides and angles. Remember, we always talk about sides and angles. And you understand, are we talking about a side or are we talking about an angle? So you want to keep these two items straight of parallelograms and to use relationships among diagonals of parallelograms. The diagonals are like going across from one corner to the other. So it's not straight, it's across, okay? Diagonals. So over here in this box, we're only going to look at the very first sentence. A parallelogram is a quadrilateral. A quadrilateral is any four-sided figure. And I'll say closed figure. So it could be a square, a rectangle, anything. It doesn't even have to have a name. As long as it's got four sides and it's closed, it's called a quadrilateral. A parallelogram is a special quadrilateral and it has certain properties, right? Those are the ones we're going to explore. So a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So what they're saying is that the opposite sides are parallel. Do you see these little arrows? Those indicate that the lines are parallel. And these two sides are parallel to each other, and that needs two arrows because it's two different sides that are parallel. Okay, that's the symbols you need to watch for. If the symbols aren't there, you cannot assume that the lines are parallel just because they look like they are. It has to be either given in the question or you need to see these symbols. And I believe one of the homework questions will kind of use this in your answer. So maybe that's a little clue, okay? Essential understanding. Parallelograms have special properties regarding their sides, angles, and diagonals. So there's three things you are going to have to keep straight. What are we looking at? And I want you to always look at your notes one more time before you start on the homework problems, because sometimes I get questions that are obvious from the notes, but then nobody ever looks at them again. So yes, you do need to read your notes to really understand what's going on. And then if there's still questions, I'll be glad to answer them. But the notes are the first go-to, okay? In a quadrilateral, notice any four-sided figure, opposite sides do not, okay, let's ignore that. It's kind of too much. So here we have sides. Notice this is a side and this is a side. They're opposite. They're trying to explain what the word opposite means. This side is opposite of that side. And these two are angles. Do you see how it's written differently? That symbol angle is right there. So angle A is opposite of angle C. So these two angles are opposite. This and this is not opposite. Do you see the difference? Yeah, this side is opposite that side. This angle is opposite that angle. These two sides are also opposite, and these two angles are also opposite. Okay, so look at that. Oh, and here's a good piece of information. You can abbreviate parallelogram with this symbol. So that's how we're going to write it instead of writing out the word parallelogram each time. Okay, so this little, it's like a rectangle that's leaning to a side. Okay, so the first theorem or the first idea is if a four-sided figure is a parallelogram, then opposite sides are congruent, which means equal in measure. So let's look. If ABCD is a parallelogram, then opposite sides are congruent. You see how this is side, 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 side. Opposite sides are congruent. The tick marks show you that. So make sure you put a little highlighter to this to always kind of refer back to it. These are the main ideas. Okay, next page. Oh, you know what? I think I made this a 2-page, yep. In the middle, we're on page 271. In the middle of the page, another theorem. Here it's talking about these shaded boxes always have some information that might be useful. So if I talk about it, you should be able to go back and look it up again. Angles of a polygon, another word for sided figure, many-sided figure, not even a quadrilateral. It could have 5 or 6 sides, many-sided figures. Angles in a many-sided figure that share a side are consecutive angles. So these two angles here and here are consecutive because they share a side. Do you see that? This is the side they share. So they are next. Think of consecutive next to each other. Okay, these two angles. In the diagram, angle A and B are consecutive angles because they share side AB. There it is, okay? B and C are also consecutive because they share the side BC. So now another theorem. So this is just explaining what the word consecutive angles mean. Opposite angles, consecutive angles. And then we have a theorem. If a four-sided figure is a parallelogram, then its consecutive angles are supplementary. So consecutive angles are supplementary means the sum, when you add them, is not 180 degrees. That's what supplementary means. So the two angles that are consecutive always add up to 180 degrees, like these two. Okay. So make sure you have that highlighted. I always write read. You can use a highlighter and put a big circle around it. Okay. And we're done with this page. Now we're on page 272 on the top, practice. We're going to do number 1, find the value of X. These are consecutive. Oh, I don't even know how to spell that. Consecutive, I believe, angles. So we just learned on the previous page, their sum equals 180. So the sum means if I add 53 plus the X angle, it has to be 180. And then I subtract 53 from both sides. Get rid of that part and bring down your X, bring down your equal sign. 180 take away 53 is 7, 1, that's 6, 2, and I believe it's 127 degrees. There's our answer. Okay, same here. These are same consecutive. They're next to each other. They share one side. Sum is 180. If you know one, you can find the other by subtracting it from 180. Correct? Very simple you can find the information on the previous page if you forget, okay? Now the theorem, let's look what this one says. Parallelograms have some other special properties. Okay, what else do they have? If a four-sided figure is a parallelogram, then its opposite angles are congruent. Congruent. Same measure. Equal. That's the word. Opposite angles. Again, we're talking about angles, so keep all that straight. If ABCD is a parallelogram, then angle A and angle C are congruent and B and D are congruent. The opposite ones are equal. Okay, so that's a big one. And then there's the next one. If a quadrilateral or four-sided figure is a parallelogram, then its diagonals bisect each other. When you bisect, you always have two equal parts. In this case, because it's sides, two equal segments. So it can talk about an angle bisector or a side bisector. So a side, you got two equal segments. So if you draw the diagonal, which I told you is the one that goes across, and another diagonal, they cut each other in half. So this is exactly the same as this, and this here is exactly the same length as this. Does that make sense? It doesn't say the diagonals are equal. It does not mean that the whole diagonals are equal. It just means they cut each other in half. The only time that those diagonals would be equal would be what kind of shape do you think? This doesn't mean the diagonals are actually. There's only one shape. Actually, there are two. That makes that true, that the diagonals are equal, and that would be a rectangle and a square. But if it's a parallelogram, if the sides are tilted sideways, it doesn't have to be, it's not going to be true. One is shorter, one is longer. Okay, so that's a big thing. Make sure you highlight these or make some kind of reference with your markers in color to make sure you always look at these boxes. Now we have, this page is 273. I don't think I have anything on that one. 273, nope, we're skipping it. We're going to the next page. This one. This is page 274. Okay. You can use theorem 40 which was on the previous page to find unknown lengths in a parallelogram, like super interesting, right? Okay, so look, what do we have here? These are diagonals. I'm already zooming in on the diagram. I'm familiarizing myself with it. These are diagonals. We learned they bisect each other. So this is the same as that. Find the values of X and Y in parallelogram PQRS, PQRS at the right. What are PR and SQ? So we got two questions here. We got to find X and Y. And once we found them, we plug them back in to answer the second part. So plug X and Y back in to problem because we want to know the length. So that's always the thing. So let's look. We got to find X, setting up some kind of equations. We know this is equal to that. That means 3y minus 7 is equal to 2x. Well, look, we got X and Y, two different variables. Darn it, we cannot solve this equation if we have two variables. So we need another equation. That's going to be this one. This and this is equal, right? Because they bisect each other. X plus 1 equals, and this is called y. Okay, another equation with x and y. Watch what I'm going to do. It says here y equals x plus 1. I'm going to reverse it just for your sake to see. Y equals x plus 1. So I'm taking the answer for y and plugging it in here for y, because these are equal. So I can substitute that. So now I have 3, but in place of y, I'm writing x plus 1. And finishing the question. And now if you look, you got an equation with only x. This is called substitution. So in place of y, I'm putting the answer what y is. So 3x plus 3 minus 7. Combine like terms. 3 minus 7 is -4. And subtract 3x from both sides. -4 is -1x. And then I have divide by -1. +4. So x is 4, and I can find y. I'll just plug it in here, because I need x and y to answer the last part. Actually, we do need x and y because it says find the values of x and y. Obedient students we are. We follow like little sheep. Y equals x is 4. So I'm taking that and plugging it in here. So now I know what y is, right? X is 4, y is 5, correct? So that's the first part. Find the values of x and y. Now we need to plug them in to get PR and SQ. PR, SQ, okay. 3y minus 7. 3 times 5 is 15. 15 minus 7, 8. So this is 8. 2x is 2 times 4. That's also 8, which makes sense since they're equal. So PR, the whole thing, PR from here to here is 16. 8 plus 8. And SQ, so we have to plug in x plus 1. 4 plus 1 is 5. And let me guess, this got to be 5 too. So it's 10. Look it over. This is a very tricky question. You might not be familiar with substituting. So look it, pause it, copy it good, watch it one more time. You'll have one of these on homework, okay? And then in problem 3, which this is one, does it matter which variable you solve for first? Nope, absolutely not. It does not, because it's just whichever one is easier. I picked that one because y is alone. Y is x plus 1. It just made it so easy to plug it in here for y, but it doesn't matter. I was going to show you one more of these. I'm not sure if that's a waste of time. This one, you have to label it yourself. That's the only thing. I will write it out, pause the video, and you can look at it when I'm done and see what's going on. So the video doesn't get so long. So I labeled my picture with what's given here. with all the segments. I wrote the parts next to it, and then I wrote the two equations. This is equal to that, and this is equal to that, because they're diagonals. So now I have two equations. I want you to try yourself and see if you can solve this, and pause the video and then check with me how I solved it, if you got the other answer. Okay, and there it is. See, look at my answers are X is 6 and Y is 8. Let's see if you got that too. If not, check it out, what happened. And in this question, they're only asking us to find the values of X and Y. They're not asking us to find Q, S, and PR. So we're done. We don't have to do any more because of that. Okay. So there you are. Next page, is it on here? Yep. Up here on page 275, it will tell you something about parallel lines and transversals. So if you have 3 or more parallel lines that are cut off by transversals, you're going to have all these segments here and here are congruent. And same on the other side. You can have as many transversals as you want, but the parallel line will make, yeah, so if AB is parallel to CD and CD is parallel to EF and AC is congruent to CE, then, so if these two are congruent, all of these are congruent as well. Not to this one, but to itself. You see, but the part has to be that this has to be true, that these two must be congruent. Then if I draw any more, they'll also have equal parts. Okay, so look at the question here. I wanted to do this one down here. In the figure, PQ equals QR. Let me look, where is PQ? This one, PQ equals QR equals RS. So all of these are equal. So I'm marking them with a tick mark. That's what's given in the question. Find each length. So what do we have here? So all of these are equal. So this was 225. This is 225. This is 3, then this is 3, and this is 3. But they're not giving us any clues about these. There's no number anywhere. So all I can find are this, 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 this. ZU, CU, where are you? So many. CU is 3. WV, the whole thing from here to here is 2.25 times 3, which I think is 6.75. Yep, I think that's true. And then that's it, I think. Yep. So I just wanted you to see that. And then we will go on to, I believe this is our homework. This is page 276. So now your turn. Now what I've found weird is that they're giving you the first question, but there was no example in the lesson. So I'm going to get you started on that. So for number 8, so let's do this homework. Use the diagram of parallelogram ABCD to find each value. Measure angle A. Well, there's 127, so that's my clue. That one is okay. You can find that really easy. Consecutive. Angles are supplementary. look up what the word means. I wrote it down for you in the notes. Okay, so then you can find that. And you can find D because opposite angles are equal. But then X, number 10. So that was number 9. Number 10, the X. Remember, opposite sides are equal. Because it's a parallelogram, it's given. Given it's a parallelogram. Opposite sides are equal. So what would be my equation? The equation would be x plus 2 is equal to 2x minus 3. And then you solve it. Okay, and find x, and I think, and then AB. Yeah, then you plug it back in. Plug in x from number 10. Yeah, when you found x, you plug it in, and then you find AB. So those are the ones. Let's see what else I have found for you. Number 12. I just showed you these are, so if these are equal, these are equal. So that one is 12 as well. And page 277, number 13. Number 14, I talked about what the difference is. Look up in your notes. And then skip 15. On this page, now we're getting into the algebra. So lots of solving equations. Opposite angles, these are angles. These are congruent. So that's your clue how to write the equation and find it. You don't have any room here, so you might want to squeeze it or do it on a separate piece of paper and insert it. So when I look at your homework, I'll see you did it. So yeah, or you can write it here. This one is the one that's challenged. That's the one with the 2 equations with 2 unknowns where you have to substitute something. Oh no, look. They have 1 variable. Oh, this is actually pretty easy. It's not like because 6y plus 1 equals 4y plus 9. You only have 1 variable in each equation. So it's not a challenge. It's just simple equations. And then this picture here is like I always like looking for real stuff that you can connect with. Studio lighting. It says a pantograph is an expandable device like that. It goes up and down, right? Shown at the right. Pantographs are used in television industry in positioning, lighting and other equipment. So if you have to go up to the ceiling, you know, they have high ceilings in those studios. In the photo points D, E, F, and G, there they are vertices of a parallelogram. So this is a parallelogram. Okay. The parallelogram DEFG is one of many parallelograms that change shape as the pantograph extends, going up and down. They squeeze it together and extend. So now your job is to look at these questions. Super easy once you understand the theorems we talked about. And I think that's it. Yep. That's it. Good luck to you guys. See you next week.